So, welcome back to the School Science Shed. This is episode 5 of a series of videos that are aimed to help you to revise for your physics GCSE if you are studying in England. Now, as I've said in all of the other videos, if you're not in England, I still think this could be a useful video for you to watch. But you do need to check your curriculum to make sure that it's covering material that's relevant to you. And even if you are in England, don't rely on the contents of my videos to make sure that you've covered everything. Do check your syllabus and make sure you've covered everything that you need to know. In this video, we're going to have a look at energy resources. And by energy resources, what I'm going to focus on is using different resources to generate electricity. Let's make a start. So there are some problems to do with supplying electricity. And again, I'm focusing on electricity for this particular video. The first thing is that the demand for energy in the form of electrical energy is increasing over time. And the other problem that we've got is a lot of the ways that we are currently generating electricity involve producing pollution and particularly making a contribution to global warming. So in the future, we are going to need to make decisions about how we supply electrical energy. How are we going to make this extra electrical energy that's going to be required, and how are we going to do it without polluting the environment? And this will show you the scope of the problem. So we've got some information here going back to about 1995 about how much energy, electrical energy, was required up to 2020. Now this video is done in 2021, so we don't have the information for 2021, but we can predict how much energy is going to be required in the future. And this line has got a prediction up to 2050, and you can see it's a steadily increasing trend in terms of the amount of energy that's required, so that by 2050 we're going to need over 700 exajoules. Now an exajoule is a big unit. We've got to use big units, haven't we, because we're talking about large amounts of energy. If we're talking about how much energy is consumed across the whole world in a year, it's going to be a very big number, isn't it? And this is how big it is. It's a 1 with 3, 6, 9, 12, 14 zeros after it. That's what an exajoule is. So that's a problem to be solved. How are we going to be generating all this extra electrical energy? Why is the demand going up? Well, there are 3 things to think about. First of all, in developing countries, lots of people are moving from the rural areas where they are not using a lot of electrical energy to towns and cities where they are using a lot of electrical energy. So in developing countries, the demand for electrical energy is increasing. Second thing is that the world population is increasing, and it makes sense, doesn't it? As the world population increases, more people means there's going to be more demand for electrical energy. And then the third factor, which is probably less important than you would think, is that we have more and more electrical appliances, and we have electrical appliances which are doing things which in the past we wouldn't have used an electrical appliance for at all. That is balanced quite a lot by the fact that these electrical appliances are more efficient, and therefore even though we've got more of them, they're not wasting as much energy, and therefore it's not making a big difference to the amount of energy that's required. So that's why the energy is increasing. Now, there are some problems which are specific to the UK. So if you're not from the UK, I think you can tune out of this. But we've got a couple of problems in the UK. The first one is, and this will be true for lots of other countries as well, we are encouraging people to use electrically rechargeable battery vehicles to move around instead of using petrol and diesel. And if we're doing that, the electricity that charges those vehicles has to be generated. So we're going to have a very big increase in demand for electrical energy in the UK in order to recharge all these vehicles. And the second problem we've got in the UK is a lot of our nuclear power stations are coming to the end of their useful life, and we're going to need to replace them. And we need to decide what we're going to replace them with. And we've got some choices. We've got some non-renewable choices, and we've got some renewable choices. And let me just make sure you understand what we mean by renewable energy. A renewable energy source is replaced as quickly as it's used. So, for example, if you are using wind energy, the wind blows on Monday and generates electricity for you, and then on Tuesday, if you're lucky, the wind will blow again. So it's being replaced as quickly as it's used. Non-renewable, things like fossil fuels, are not replaced as quickly as they're used. And the inference there is if they're not being replaced as quickly as they're used, then eventually they're going to run out. So that's the difference between renewables and non-renewables. There's quite a few renewable options. So you've got the main ones there. You've got wind energy, you've got solar, hydroelectric, geothermal, biomass and tidal. And what we're going to do in this video is we're going to look at each of these different resources, and we are going to see how they work, how do they generate electricity, and we're also going to look at some of the advantages and disadvantages of each type. If we're going to do that, we need to think about the economy of generating electricity. How much does it cost? And if you are working out how much it costs, you can't just look at the fuel that you're using. So please don't, under any circumstances, say that something like wind energy gives you free energy. It doesn't. Why doesn't it? Because there are some things that you have to pay for if you are generating electricity. You've got to pay to build the facility that's generating your electricity, whether it's a wind farm or a nuclear power station. You've got some building to do, and that is going to cost you money. Those are the setup costs. You've then got to keep everything working properly. That's the maintenance cost. And you've also got to, if it requires a fuel, and not all of these do require fuels, but if it requires a fuel, you've got to pay for the fuel. And then finally, at the end of the useful life of your power station, you've got to dismantle it and return the land to its previous use. And that's the decommissioning costs. So there are 4 things you've got to pay for. And if you've got something which has got 0 fuel costs, that's certainly an advantage, but it doesn't mean that it's free, because you are going to have to pay for the other 3 things. And as well as economics, you need to think about some other things as well. So your way of generating electricity, is it reliable? Do you know that at a particular time it's going to be able to generate electricity for you? And lots of the renewables like solar and wind are weather dependent, so they're not reliable. Similar to reliability is whether it's continuous or intermittent. So to explain what that means, if we just compare wind energy with tidal energy, with tidal energy, it can't supply energy any time that you want it to. It's only going to supply energy when you've got a big difference between levels of water. So effectively, when the tide's coming in, it will generate electricity, and when the tide's going out, it will generate electricity. But that's not happening all the time, so it can't generate electricity continuously. It is, however, extremely reliable, because you can predict what time high tide and low tide are going to be on a particular day for hundreds of years in the future. So you know, if you've got a tidal system generating electricity, you know when it's going to generate the electricity for you and when it's not. So it is reliable. It's reliable, but it's not giving you a continuous supply. Wind energy isn't reliable either, and it's not giving you a continuous supply, so it doesn't tick either of those boxes. Startup time, what's that about? Well, what's going on there is, I don't know if you've ever thought about how difficult it is to plan energy supply for a country. But basically what you don't want to be generating electrical energy when people don't need it, because that's not going to be efficient. So, and also you want your power stations, they're most efficient when they're running at their full power output. So what you want to be able to do is to switch on a power station when the demand starts to become high. But how long does it take to get a power station up and running? Well, if it's a nuclear power station, it takes days. But if it's a hydroelectric power station, it can get up and running in a few minutes. And that time, the time it takes to get up and running, is called the startup time. And you also need to think about the environmental impact, especially climate change, because that's a particularly severe environmental challenge, but it's not the only environmental impact. So again, please don't say, if you're asked about advantages, that any of these ways of generating electricity are environmentally friendly. That's a very vague thing, and we don't like vague ideas in physics. And also, all of them have some bad impact on the environment. So none of them are environmentally friendly. So if you want to say that there's an advantage of one particular way of generating electricity because it doesn't have a particular bad effect, so maybe it doesn't produce carbon dioxide, so it doesn't contribute to global warming, doesn't contribute to climate change, don't say it's environmentally friendly, say it doesn't contribute to climate change. Because whatever it is, it will have some negative impact on the environment. So what I want to do is I want to explain to you how each of these resources for generating electricity is used to make electricity, and talk about some of the advantages and disadvantages of each sort. So let's start with fossil fuels. Here's a diagram of a fossil fuel power station. It's actually a coal power station, but oil power stations and some gas power stations work in the same way. Let's start with the boiler, which is this part here, and that is where, no, let's not start with the boiler, let's start with the furnace. It's this part here, and in the furnace the fuel is burnt. That's what the furnace is. It's the place where the fuel is burnt. And then near to the furnace there is an arrangement which can boil water. So water goes in as a liquid, and once it's in there it's heated up and it boils. And because it's boiled, it turns into a gas and expands and passes along a pipe like this. And it moves along that pipe quickly. We've got high pressure steam here moving very fast. And the high pressure steam goes past a turbine. Now a turbine is like a propeller with lots and lots of blades. We'll have a look at a picture of one in a minute. So as the steam rushes past that, it turns that axle, and the turbine is connected to a generator, and it's the generator that transfers the electrical energy and causes the voltage and makes the current flow. And then we've got a transformer here, which we will talk about in another lesson. And once the steam has passed the turbine, you need to turn it back into water so you can boil it again. So you cool it down, turns back into water, and it goes round as a cycle. That's how a fossil fuel power station works. So we've got a summary of it there. So if you wanted a few sentences to explain how a power station works, there they are on the screen. If you want to pause the video and copy those down as part of your notes, that's fine. Otherwise, just read them. And let's have a look at those different parts of the syllabus of the power station. So furnace is where the fuel is burnt. This is not a furnace from a power station. It's actually a furnace from a static steam engine, so it's much smaller. The boiler is where the water is boiled to produce high pressure steam. Here is a turbine. You see what I mean? It's got a central axle which has got quite a big diameter, and then it's got lots of blades like a propeller, but many blades which make it turn when the steam goes past. Then there's a generator. Again, this is a small generator, and we'll have a look at what generators are like inside in a couple of seconds. And then we're not going to talk about how a transformer works or what it does this video, but we will cover it later on. And because the generator part is used in lots of different power stations, not just those that use fossil fuels, it's worth just talking a little bit about what they contain. We'll talk in more detail about this when we come to the magnetism topic. But for now, a generator could be made by having a coil of wire and a magnet that spins inside. Alternatively, the magnet could stay still and you could turn the coil. Both of those things will generate a voltage. So that's how a generator works, and we'll be talking about generators making voltages in other ways of generating electricity as well. So what are the advantages of a fossil fuel power station? Well, it's fairly quick to start up. If you want to start generating electricity because the demand is high, it's only going to take you a few hours to get your power station working. And provided you're confident about your supply of fuel, it's reliable. It's going to work any day of the week, and you know it's going to work. So those are the advantages of fossil fuel power stations. What are the disadvantages? Well, the main disadvantages are that it produces air pollution and it also produces carbon dioxide, which contributes to global warming. So it's not good for climate change. And also, it's non-renewable. So eventually the fossil fuels, coal, oil and gas, are going to run out. So what are the alternatives? Well, you could generate your electricity using nuclear power. And if you look at this diagram, what you'll see is that it works in a similar way to the fossil fuel power station. In fact, this blue bit is the same as the fossil fuel power station. So we've got water, which is being boiled and producing high pressure steam, rushing past the turbine, turning the generator and making the electricity. What's different is how the heat is produced. So instead of burning something to produce the heat, you've got a nuclear reaction going on in this reaction vessel, and then some sort of liquid or gas which transfers the heat to boil the water. And what that is that's transferring the heat will depend on the design of the nuclear power station. So some nuclear power stations use water, some use gas, some use air, and others use melt. If it's a really old-fashioned one, it might use molten sodium to transfer the heat. So we've actually got two liquid circulations, or two. One might be a gas. That might be a gas. This bit transfers the heat to the boiler, and then the water boils in the boiler, produces high pressure steam, and so on. So that's how a nuclear power station works. The actual details of what's going on in that reactor vessel we'll talk about when we come to the radioactivity topic. Let's take a look at the advantages of nuclear power. And the two main advantages are that, first of all, the fuel itself is cheap and it contains a lot of energy per kilogram. A kilogram of uranium fuel from a nuclear power station contains a lot more energy than, say, a kilogram of coal or a kilogram of oil or a kilogram of gas. So the fuel contains a lot of energy and it doesn't cost you very much to buy. And then the other advantage, which is really significant, is provided nothing goes wrong, there's no pollution released into the air and it doesn't produce carbon dioxide. So if you are interested in a way of generating electricity that doesn't contribute to global warming, nuclear power is definitely something you should consider. But lots of people think that nuclear power is not the solution to climate change. And why do they think that? Well, first of all, it's expensive to build nuclear power stations, and it's very expensive to decommission them. Because when you're decommissioning them, anything that's been contaminated with the radioactive waste needs to be treated really carefully. It takes several days for them to get going. So basically, if you've got a nuclear power station, it's got to be running all the time. Because if you turn it off, it's going to be off for ages. So you would only turn it off if you absolutely had to. Otherwise, it's going to be running all the time. Nuclear power stations produce lots of highly radioactive waste. And that radioactive waste needs to be stored carefully for hundreds of years. So that is putting quite a burden on people in the future. We produce electricity. By producing electricity, we make all this waste, and then we say to our children, our grandchildren, our great-grandchildren, you've got to keep this waste safe. And if there was an accident, and there have been accidents, which I'm sure you're aware of, that releases very dangerous radioactive waste. So those are the disadvantages of nuclear power. Let's talk about wind energy. How does wind energy work? Actually, before I explain about wind energy, I think I really need to talk to you about being careful to distinguish between energy forms, which we talked about in episode 2, and energy resources, because we often put the word energy after both of them. We talk about wind energy or hydroelectric energy. Now, wind and hydroelectric are not energy forms. They are resources that you can use, like the wind or water behind a dam, to generate electricity. So just keep those two things separate in your head so you know the difference between the two. So wind energy, how would we harness wind energy? Well, what we would do is we would have what's called a wind turbine, which is like a propeller. This particular wind turbine's got 3 blades. The wind blows, it turns the blades, and then they are directly attached to a generator. So in there are some magnets which spin around near a coil, and that's what produces the voltage to generate the electricity. What are the advantages then of wind energy? Well, first of all, there's no fuel cost. Don't say it's free. It's not free. You've got to build the wind turbines. You've got to maintain the wind turbines. When they're too old to work anymore, you've got to take them down and dispose of them. All of that costs money. So it's not free. But it doesn't need fuel, so there are 0 fuel costs. It doesn't pollute the air, and it doesn't contribute to global warming. And it's renewable. So all of those are advantages. What are the disadvantages? Well, it's not reliable. It only works when it's windy enough. And in fact, if it's too windy, you have to stop them as well, or they'll be damaged. So it only works when the wind conditions are suitable. They do take up a lot of space. They make noise, which can be annoying to people, and it can affect wildlife. And lots of people also think they're ugly. So all of those are disadvantages of using wind turbines. An alternative to wind turbines is solar energy. This is another renewable source, and it's unique because it doesn't use a generator to make the electricity. The light falling on the solar panels is transferred directly into electrical energy. There's no turbine and there's no generator. It just transfers light into electrical energy straight away. So what are the advantages? Well, like wind energy, there's no fuel costs, so there's 0 fuel costs. Also, like wind energy, it doesn't pollute the air or contribute to global warming, and it's also renewable. But similar to wind energy, it only works at certain times. You don't need it to actually be sunny for it to generate electricity. Though obviously when it is sunny, it generates more electricity. But you do need a certain light level. So on a very dull day, it's not going to generate electricity, and it's not going to generate electricity at night either. Like the wind turbines, they take up a lot of space, and the solar panels themselves are quite expensive, although the price is dropping. I'm almost wondering if I want to leave this video up on YouTube for a long time, eventually that's not going to be true. Eventually they're not going to be that expensive, because the more of them are made, the less they actually cost. So at the moment they're expensive to set up, but the costs are falling. Another way of generating electricity is hydroelectric energy. So the idea with hydroelectric energy is that you build a dam to trap some water, and behind that dam you will cause quite a lot of flooding. And then what you do is you allow the water to go through a pipe, and as it goes through a pipe it turns a turbine which generates electricity, and then you return it to the river that you've dammed. So that's how it works. What are the advantages and disadvantages? Well, again, 0 fuel costs. There's no fuel. You're using moving water. And like the last two renewable sources we looked at, it doesn't pollute the air because you're not burning anything, and it doesn't contribute to global warming. It's renewable. Unlike the other two, it's also reliable because you only bother to build these things in areas where there is high rainfall and mountains. And the high rainfall means there's always going to be some water behind your dam so that you can use it. And it's also got a very fast start-up because all you need to do is just open the valve and let the water flow, and it's generating electricity straight away. It can do it in, if not seconds, certainly in minutes. So it's very fast to get going. What about the disadvantages? Well, it's only going to work if you've got high hills or mountains and good rainfall. So it's only suitable for some areas. And the lake that you make when you build the dam will flood a lot of land. So it's got that environmental impact. And it's also very expensive to set up. You've got to build a big dam. You've got to make sure it's safe. And you've got to buy the land that you're flooding as well. Because if you flood somebody's land, they are going to expect you to pay for it. So it's very expensive to set up. What about geothermal? Well, the clue is in the name. Geo is to do with the earth and thermal is to do with heat. And you probably know that if you go down below the earth's surface, the rocks get hotter and hotter. What you may not know is that in certain parts of the world, the hot rocks are quite close to the surface. And that's certainly true in Iceland, which has a lot of volcanoes. So the hot rocks are really close to the surface. But it's also true in parts of England as well. So in Cornwall, Cheltenham is another place, Bath, Droitwich. These are all places where the hot rocks are quite close to the surface. So if you've got that situation, what you can do is you can drill a hole down to the hot rocks. You can pump water down, and when it's there, it will, because the rocks are so hot, it will boil and produce steam, and then the steam can go up a pipe, turn a turbine which is connected to a generator, and then you cool the water down so you can send it back down to the rocks to boil it again. That's geothermal. So what are the advantages of geothermal? Well, again, zero fuel costs because you're not burning any fuel. And because you're not burning anything, it's not going to pollute the air, and it's not going to contribute to global warming. It's renewable because there is so much thermal energy in those rocks that even the bit where it cools down, where you send the water to boil it, it will just conduct more heat, back to those areas it's replaced as quickly as it's used. It's reliable because the rocks are always hot. And it can produce electricity all the time as well. And it's quite fast to start up. So those are the advantages. What are the disadvantages? Well, it's only cost effective. I mean, you could use it anywhere if you drill down far enough, but it's only cost effective where the hot rocks are close to the surface, and it's an expensive thing to set up. Biomass. Now, biomass energy, we give it one name, but actually there's a whole range of different things that you can do, which you would call biomass energy. Basically, any method of generating electricity that uses material from living things is biomass. So there's a couple of examples there. You can grow trees. If you wanted to do this, you would choose trees that grow really quickly. Willow's a good example. So you grow willow, you cut the willow down, you dry it, you burn it in the same way that you would burn fossil fuels. In fact, you can use willow in a coal-fired power station, burn the wood instead of coal. Anaerobic digesters are places where you let things decompose without any air. That's what anaerobic means, without any oxygen. And when you do that, one of the things that's produced is methane, and you can burn. Methane is basically what's in natural gas, so you can burn it and use it in the same way as natural gas. So that's biomass. What are the advantages? Well, it's renewable and it's reliable. It's fast to start up. And the fourth bullet point needs a bit of explaining. There's no net contribution to atmospheric carbon dioxide. So let's say you're burning wood. Now, there's a lot of carbon in wood, so when you burn it, you get carbon dioxide. So when you burn the wood, you are adding carbon dioxide to the atmosphere. But you are adding the same amount of carbon dioxide to the atmosphere as was taken in by the trees when they were growing. So overall, over the whole thing, the trees growing and then being burnt, there's no extra carbon dioxide being added. That's what no net contribution to atmospheric carbon dioxide means. And some methods of using biomass energy can be a way of dealing with organic waste from living things. So in my local authority area, they collect food waste from the kitchens. And what they do with that food waste is they take it to an anaerobic digester where it decomposes, so you're getting rid of the waste. Whatever's left over afterwards is good fertiliser, and it's also producing methane which you can burn. And again, because those things have grown, they're either plants which have taken carbon dioxide in from the atmosphere, or they're animals which have eaten plants, and those plants took carbon dioxide in from the atmosphere, so there's no net contribution to atmospheric carbon dioxide. What are the disadvantages? Well, it depends where you get your biomass from. I can't think of very many. We'll talk about the last bullet point in a minute. But using food waste to produce methane, can't think of many disadvantages of that at all. But in some schemes for producing biomass energy, you are using land to grow things like willow trees that you could use to produce food instead. And one of the reasons we need all this extra energy is to do with population growth across the world. And as well as needing electricity, people also need food. So if you are using land that could be used for food and as a result people are going hungry, that's not a very good choice. And then they do release pollution. So when you burn these fuels, it releases pollution into the atmosphere, even though actually the net effect on carbon dioxide is zero. Let's talk about tidal. Now, tidal is very similar to hydroelectric, except the idea with tidal is you have an estuary, which is where a river meets the sea. And what you can do at an estuary is you can build a barrier across the estuary. And then you create behind that barrier what's called a lagoon. And obviously on the other side of the barrier, we've got the sea. Now, if the tide comes in, what you end up with is this picture here, where the sea is higher than the water in the lagoon. So you let the water move from the high level in the sea into the lagoon, past the turbine turns a generator, you're making electricity. When the tide goes out, you get the opposite. The water behind the lagoon is higher than the sea, so you let the water move out of the lagoon into the sea, and that turns the turbine and also generates electricity. So what are the advantages and disadvantages? Well, it's renewable because the tide's going to keep working. It's reliable because you know when the tide's going to come in and when it's going to go out, but you can't actually use it to generate electricity 24 hours a day. You need the tide to be coming in, or you need the tide to be going out. So it's reliable, but it doesn't generate continuous electricity. There's no fuel, so we've got zero fuel costs, and it doesn't have any air pollution, so it doesn't contribute to global warming. But what are the disadvantages? Well, like hydroelectric, it's expensive because you've got to build that barrier, and that's a technical challenge, costs a lot of money. It only generates electricity at some times. Only some places are suitable, so you need an estuary. And not everywhere, we're probably not aware of this living in England, where the tide, what we call the tidal range, that's the difference between low tide and high tide. In England, the tidal range is quite high, but not every part of the world has a big tidal range. So if you haven't got a big tidal range, it's not going to work, and you need an estuary. So you can't just build it anywhere on the coast. You need somewhere where a river's going into the sea. And then when you put that barrier in the way and you affect the tides, you interfere with the tides, that has a very significant effect on the ecosystems within the estuary. So it's got quite a big environmental impact. And the last thing I want to talk to you about in terms of generating electricity, because we've looked at all of them, the last thing I want to talk to you about is pump storage. So one of the things I've already told you is what you don't want to do, if you can possibly avoid it, is to be generating electricity that people are not using. And these pump storage schemes are a solution to that problem. And they can also be used. There are certain circumstances where, particularly in England, where we're getting a lot of wind energy and a lot of solar energy. If it's a windy, sunny day, we're getting a lot of those types of energy. All the nuclear power stations are running all the time because that's what they need to do. And you might be generating more electricity than is actually being used. Well, if that's happening, we can use a pump storage scheme. What we've got with a pump storage scheme is two lakes, one high up and one low down, and we connect them with a tunnel that will allow water to transfer between the two. If we're generating more electricity than is being used, we use the extra energy to pump water from the low lake up to the top lake. And that means the top lake can store energy as gravitational potential energy, or in the gravitational potential energy store if you prefer. And then when you need it, and like hydroelectric, you can do this in minutes, you let the water fall and turn the turbine. This thing here is labelled turbine, but it actually acts as a pump as well. When you've got extra energy, you pump the water up. And when you need to generate electricity, you let the water fall and turn the turbine. So that is a pump storage scheme. So I'm hoping that by going through those things, you've got a clear idea in your head now about the different ways of generating electricity, some of the advantages and disadvantages, and how those things work. If it has been useful, please click the thumbs, give it a thumbs up. If you've got any questions, put those in the comments and I'll try and get to answer them. I've really enjoyed explaining to you about energy resources, and I'm looking forward to the next episode. But until then, good luck with your revision.